Yeah, hello students. Greetings of the day. This is your NE Rao, faculty in physics from VIP classes. Right? Yeah, let us have today now NEET coming discussion. For the Thank you. Analysis, if you see, yeah, physics paper was easy to moderate. You can say, yeah, in student point of view, anyhow you have to solve 45 questions. No, so you can say here lengthy calculations only. Some are one or two questions. Okay, so paper you can say. Easy to moderate we can say, but for student point of view మీకు moderate అనుకోవచ్చు, teacher point of view easy అనుకోవచ్చు, but you have to bear what you can call at that tempo of the examination, that particular tension and all. No, so in that one you may do small silly mistakes, so that may fetch some negative marking kind of thing for all of you. So anyhow, so compared to last year 2025 paper analysis, if you compare this time physics, you can say easy only. Okay, right, let us see the students questions. Now first question is saying, so you see, so 100 number closely, okay, 100 turn closely wound circular coil of radius 5 centimeter has a magnetic field is given. Okay, current flowing through the coil and magnetic moment of the coil is asking, right? So if you consider, so circular coil has 100 number of turns, isn't it? So if you take, so 100 number of turns, if you see magnetic field, first of all you should know the formula. Magnetic field, center of a circular coil is how much? Mu naught I by 2r, but n number of turns are there, so n. So magnetic field value is given here for you. Magnetic field value is 3.14 in 10 power minus 3 Tesla. So from that you first find the value of I. Once you find the value of I, what is the formula for magnetic dipole moment? Magnetic dipole moment mu bar, or some books say m bar, is equal to I into area vector, isn't it? So I into what? Area vector. So first find the value of I here. So field value is given as 3.14 into 10 power minus 3 Tesla, students, which is equal to, and B value this much. So n number of turns is 100 and mu naught value is 4 pi into 10 power minus 7, right? And current value itself we have to calculate, isn't it? Current value we have to calculate, right? So mu naught into n into I by 2 into r. Okay, so radius of the coil is given as 5 centimeter. Convert in SI system, 5 in 10 power minus 2. Okay, so now if you simplify this one, see pi value is 3.14, you can cancel either side, and this is 10 in 10 power minus 2, 10 power minus 1, transfer left side, it becomes 10 power minus 4, right? So 10 power minus 4, and then this will be 10 power minus 5 into I. Okay, so 3.14 in 10 power minus 3, mu naught value is 4 pi in 10 power minus 7. Current value you have to find out, n is 100 turns by 2 into r. R value is 5 into 10 power minus 2 centimeters given, right? So you can find out in terms of meters, you can find out. Yes or no? So if you simplify, so the value of the current will be how much comes to be. Okay, 1 by 4 is there, no? So I, so 10 power minus 5 into I, 4 is also there, right? So 4i. So if you consider I value will be 1 by 4 into this will come this side, so it becomes 10. So this is 2 2s are 2 5s are 5 by 2 means 2.5 ampere. So current will be 2.5 ampere. So in two options it is given, so either of this you have to choose now. Okay, current is 2.5 ampere. Now what is magnetic dipole moment, right? I into A. So but n number of turns are there, so into n you can do. So n is 100, current is 2.5 ampere into area pi r square, right? So r square means 5 into 10 power minus 2 whole square. Why? Radius is given in terms of what, student? Radius is given in terms of centimeters. Okay, so if you simplify, this will be 250, because decimal one you can cancel. So pi value is 3.14 into, so this is 25 into 10 power minus 4, right? So if you consider this is 625, right? 25 and 0 is there, so 10 power minus 3 into 3.14. So approximately 625 into 3 1875, approximately 1900. So 1.9 some change will come. 1.97 means you can nearly round off to 2 ampere meter square. Okay, therefore you can make it as 2 ampere meter square. In that sense, first option will be your right answer. Okay, students. Yeah, so next you see this question. See, first question is based in the basic formula for magnetic field. from magnetostatics, you can say moving charges magnetism. Okay, yeah, moving charges magnetism. Next, coming for second question, match the column from modern physics part it is. So energy of the photon, you know, all of you, E is equal to h mu, energy of photon. So first E you can balance with 4 here, and diffraction and interference, they are wave nature of light, right? So you can mark as 3. Lambda is h by p, you know, de Broglie wavelength lambda formula is h by p, right? So wave nature de Broglie wavelength is given directly, so this is 1. And then Compton effect, which is for particle nature of light, so you can say 2. So you can say 4 3 1 2, 4 3 1 2. So option A. Okay, right, students. Now coming for, this is for modern physics, means radiation matter, you can say. Okay, dual nature it has been asked, right? Now coming for next question, you see there are diodes are there, and we're applying potential of how much here? Potential of 10 volts we're applying. Okay, so 4 ohm, 3 ohm. Now if you consider this is plus, no, so this will be here plus, this will be here minus, this is plus minus, this is minus plus, this is plus minus. Why? Because we're applying a potential of the battery like this here. These points will be, okay, this is will be high potential, this will be low potential. Okay, always. Now if you see for this diode D1, if you consider, diode will forward bias. Okay, p type connected to positive. Here this is n type, this is p type. N type negative, so this is reverse bias. Next here positive, here negative, no. So what happens? P connected to positive, so this will be forward bias, and again this is reverse bias. So these crossed diodes which I made now, they can't conduct, they will be in reverse bias. Okay, so forward bias, you can say only how many are there? 2 diodes are there. So I will write the circuit down here like this. See, now its resistance how much? 4 ohm is given, right? And second diode will be reverse bias, need not to consider. And second, next third diode, you see forward bias, and how much resistance is given here? That is 2 ohm. You can write here 2 ohm. And first one is how much? That is 4 ohm, right? This is 4 ohm. And next, what is saying? And third, okay, fourth again in reverse bias. So only 2 diodes are there. So current is, so you have to find out this whole 10 volts is given. Okay, 10 volts is given. Now you can calculate, was asked the current I in the circuit is asking. So these 2 diodes were in forward bias, and these 2 resistors of these 2 diodes will be what? So you can take in forward bias like conducting diode, isn't it? So 2 resistors 4 and 2 ohm are in parallel. So what the formula for the parallel combination? So 1 by R will be is equal to 1 by R1 plus 1 by R2. Yes or no? So if you write equivalent resistance value, or direct R1 R2 by R1 plus R2 also you can use if you are perfect. Okay, you can use parallel combination R1 R2 by R1 plus R2. So from there you can find out the value of what? Yes, now R equivalent you can find out. So R equivalent will be, this is 4 into 2 by 4 plus 2 is 6. So you can get here R equivalent is 4 by 3 ohms, students. Okay, now if you get 4 by 3 ohms, this one, we have to find out I value. So I is equal to V by R. So applied potential is 10 volts by current is here 4 by 3 ohms. If you do, this will be 30 by 4 ampere. 30 by 4 means how much, right? 15 by 2 ampere, which is equal to 7.5 ampere you will get. Okay, so like this, the question is basic question which is based on this semiconductor physics. Okay, modern physics and course. So modern physics, 2 questions now. One is radiation matter, easy question, and now this diode forward bias, reverse bias also easy. So scoring, right? So this question is again modern physics or semiconductor physics, semiconductors. Okay, yeah, let us take. So this is 15 by 2 means 7.5 ampere. Okay, this one. And coming for next question, you can see here the speed of light in vacuum is taken as unity. Okay, if light takes 6 minutes and 40 seconds to reach the earth from the sun, the distance between the sun and the earth, okay, in units, yeah, new units. So you can say this is called astronomical unit, you know, 9.1 in 10 power 11 meters distance between sun and earth. Generally if earth takes nearly 8 minutes, that calculation, isn't it? So here is saying this question, time taken is 6 minutes and 40 seconds, right? Yeah, if you convert into 6 minutes, minutes means 60 seconds, so plus again 40 seconds. So 360 plus 40 seconds. So total time how much, Ray? Directly you can say 400 seconds. Now he's saying speed of light in vacuum is 1 unit. In vacuum, how much speed of light? 3 into 10 power 8 SI units, okay, meter per second. This is asking to take 1 unit. Then astronomical unit value will be how many units in new system is saying. So speed of light or speed is equal distance by time. So distance will be how much? Speed into time. So here time is 400 seconds and speed is how much here? Vacuum or air is taken as 1 unit. So this is 1 unit and the time will be here 400 units, you can say seconds. This will be equal to 400. In new system the distance will be 400 units. Okay, so that wise you can say the earth from the distance between sun and earth new units, that is equal to 400. Okay, and next question based on I think kinematics it is. The following plot shows the variation of velocity time of a ball thrown vertically upwards and falling back. Which of the following plot is correct? Now see, for a body projected vertically upwards, okay, so we consider a body projected vertically upwards from the ground. If you project a body vertically upward, so simply you can remember direction of throw as positive. If you take direction of throw as positive, so when it is coming down again, okay, so what happens here? Velocity is gradually go on decreases. So acceleration is what? Velocity change is negative, acceleration is here negative, so slope of vt graph must be negative. And moreover, velocity decreasing becoming 0 and then direction is reverse. So if you take upward positive and downward will be what? Negative. So you can draw the graph. So keep in mind the slope into notice. So at t is equal to 0, velocity is some maximum, you are throwing vertically upward, right? And as time passes, velocity gradually decreasing at constant rate. Why? G is constant, so vt graph will be straight line, and moreover negative slope. Why? Acceleration is negative, so decreasing and becoming 0, this is negative slope. And then as time passes again, what happened? After becoming 0, direction is reverse, so v become negative and increasing at the same rate. So slope will remain same as increasing same rate, so slope will remain same. Somewhat this kind of profile graph you will get. Okay, so which option is correct here? That will be increasing, becoming decreasing, becoming 0, and so C option you can do. Okay, so graphical question is okay. Kinematics 1D motion. Kinematics 1D motion. Next question again. Say units and dimension measurement errors. In a vernier calipers, 20 vernier scale divisions coincide with 16 main scale division. Each division of the length is 1 millimeter. Okay. The least count of the vernier calipers. 20 vernier scale divisions coincide 16 main scale. So this is not standard vernier calipers. So he has given 20 vernier scale divisions, right? 20 vernier scale divisions coinciding with what? 16 main scale divisions. Okay, no issue. So generally what formula? And see, in case of NEET, this kind of model questions are repeating students. Even 2025, 24 also, they have repeated this kind of question based on vernier calipers, least count, screw gauge. Okay, standard vernier calipers principle is what? N vernier scale divisions equal to n minus 1 main scale divisions. In that case, if one main scale division is 1 millimeter, no, then least count is how much? 0.1 millimeter. But here not standard value, general formula he has given. So from here we have derived now. So one vernier scale division will be how much? 16 by 20 main scale divisions. Okay, this will be 4 4s or 4 5s. One main scale division value is 1 millimeter he is saying. This will be 0.8 millimeter. But formula for least count? Least count formula is what? So you can say least count is equal to 1 MSD minus 1 VSD. So 1 VSD 0.8 and 1 MSD 1 millimeter. So 1 millimeter minus 0.8 millimeter. How much, right? That is equal to 0.2 millimeter. Yes or no? So when 0.2 millimeter, or you can also in centimeters, so you can say 0.02 centimeters. So you can see the option how he has given. Sixth question, right? 0.02 centimeter. This option is right option. Right. So next, if you see the question, in an AC circuit contains a resistance of 1 kilo ohm, capacitance 0.1, inductor 1 millihenry. The resonance frequency. So you are having already resonance frequency in AC circuit formula is what beta? Resonance frequency in AC circuit formula is 1 by 2 pi root of LC. Okay, you substitute the values you will get, and your resistance is given, inductor capacitance is given, and capacity inductor given, resistance not required here, right? Frequency is 1 by 2 pi root LC. Simplify it and you can find the answer. So 1 by 2 pi root of, okay. Sometimes I will may leave calculations to you by I will indicate the concept, okay. And length 1 millihenry, right? 1 milli means 10 power minus 3 henry into C. C value how much? 0.1 microfarad, that is 10 power minus 1 into micro means 10 power minus 6 beta. So this becomes how much, right? This will be 1 by 2 pi root of 10 power minus 10. 10 power minus 10. So this will be how much, right? That is 1 by 2 pi. 10 power minus 5 whole square, you can say 10 power minus 5 will go up 10 power 5. So 1 by 2, 0.5 by 3. 0.5 by 3.14 into 10 power 5 hertz, right? So this will be, if you simplify further, Nana, how much will get, right? Approximately, so this is 0.3 3 ones are, okay, 3 ones are 2 left, 3 6 are 18, okay, something, and then 10 power 5. So you can simply say 16 kilohertz approximately. That is equal to option 3 will match, okay. Kilohertz 10 power 5 no into 10 power 2 in 10 power 3, decimal get cancelled and you will get it, okay. So right now here the figure below shows a long straight solid wire of cross section radius A. Magnetic field is asking, right? The plot which correctly represent the various standard question only. Like in electrostatics also we have no field in case of non-uniform conducting sphere, electric field formula like 1 by 4 pi epsilon q x by r square x whole power 3 by 2, right? So from center to surface varies linearly and outside is inverse profile, right? Inverse profile we have. Similarly here also you can say current is distributed uniformly across the cross section of a conductor, cylindrical conductor, okay, uniformly, and at a particular distance r from the center you have to find out. So you can find here I is uniform law, direct graph profile we know, but just I am deriving for the sake of you. Field is uniformly, so I is the current distributed across area, how much beta? Pi a square. So what the current in unit area, that is I by pi a square, okay. So we have to find out the current in a distance of how much? A distance r, no, with distance radius a, how it is varying, okay. Yeah, so at particular distance if you take, you can take a linear surface within the sum, how much area, this much area of pi r square. So current in the small pi r square area is di, if you consider current per unit area pi a square into that area is pi r square, okay. So this will be get cancelled, so I into r square by a square, this is the value of current in that small particular zone, okay. So now line integral b bar dot dl is mu naught into I, okay, by ampere circuit law. So by you will apply up to a certain distance, so current line integral b bar dot dl is mu naught into I. So here b value we have to find out, right? So b into dl along this way, everywhere if you see current, if you right hand rule, no, if you hold here like this everywhere, so current is what? Concentric circles, magnetic field lines will be, so along the length they are parallel, so b dl theta 0. So b in constant everywhere here, so b constant, length is 2 pi r, which is equal to mu naught into current enclosed in this amperian loop is I into r square by a square. So if you simplify, student, here this r get cancelled and a, I, everything is constant, so b proportional to what? R up to where? Up to capital A, small a radius, and outside will be anyhow inverse relation. Why? B is equal to mu naught I by 2r, right? 2 pi r. So b will be 1 by r outside, inside linear. So therefore the profile graph will be A. So linearly and inversely varying. So this you can say applications of ampere circuit law. But generally we talk in the class direct standard derivation for both NEET as well as JEE. So those who know directly you can mark it. Okay, right, students. And then coming for you can say this question. What is saying? So a uniform metallic wire having a resistance 4 ohm bent into form a square loop. So all sides equal. So each side length resistance will be how much beta? 1 ohm. So this will be 1 ohm, this will be 1 ohm, this will be 1 ohm. Okay, and a 2 ohm is connected like this, and is saying a battery of 2 volts is connected across point A and C. Fine. So you can say it's like standard this one, no, Wheatstone bridge. Why? So these 2 points across which we have connected a battery and a galvanometer kind of thing, or another resistances and other 2 points. So and resistance ratio you can see 1 by 1 is equal to 1, 1 by 1 is equal to 1. So this balance Wheatstone network, so you can neglect this resistance. Now these two resistors will be in series, these two resistors will be in series, 2 ohm, 2 ohm. They are in parallel. So what is the formula for parallel combination? R1 R2 by R1 plus R2, 2 into 2 by 2 plus 2. This will be 1 ohm. So I will be equal to V by R. So entire battery is 2. So resistance is 1 ohm, and 1 ohm, that means current will be 2 ampere. So this is balanced Wheatstone network. Okay, so current will be at 2 ampere. This student has marked wrong here. So fine, no issue. The answer should be what? 2 ampere. Okay. Yeah. Now an unknown nucleus has a nuclear density. Nuclear density is constant, right? Proportional to mass number. Nuclear density is always constant, independent of mass number. Okay. And mass of the nuclei is given. So its mass number is approximately asking. So that formula you can write. Density is mass by volume, and volume is what? 4 by 3 pi r cube. So m by 4 by 3 pi r cube. Just I will do calculation below here. Then so density is mass by volume. So this is mass by volume. How much beta? 4 by 3 pi r cube, where r is radius of the nucleus, and you know formula radius of the nucleus is r naught into a power 1 by 3. Substitute here. So you will have m by this 3 you can take numerator. So 4 pi, this will be r naught cube into a. Okay, this is density. Mass given density. Asking mass number, a is equal to what you can get now? 3m by 4 pi r naught cube into all values are given, just substitute over here. Okay, that's how you have to answer for what? Students, some calculation part, so it consumes your time, so you should be cautious for calculations. Okay, fast share నేర్చుకోవాలి మీరు. Okay now, right. Now coming for next question, you can see what is saying. 11th question. Rectangular wire loop of side 8 cm and 3 cm with a small cut is moving out of a region of uniform magnetic field of magnetic strength 0.3 Tesla. Then normal to the plane of the loop. Okay, for example, if you say this mobile as a loop, okay, this is length and this is breadth. So it's going in a magnetic field like this. It's going in a magnetic field. Okay, magnetic field is perpendicular like this. Fine. Yeah. So the EMF developed across the cut if the velocity of the loop is this much in a direction normal to the shorter side of the loop. Yeah. EMF developed across the loop and a direction normal shorter loop. Shorter and this one. Okay. Longer. So this is going like this. Okay. So BLV. So fine. So now you can see here flux is changing. Now we are having this kind of thing. So per shorter and this much. Okay. This is length and this is what? Breadth. So if you see magnetic field is pointing into, and when it is going out of the magnetic field lines, okay, entire magnetic field, when it is going out, so this length is variable, right? So if you take magnetic induced EMF is equal rate of change of magnetic flux, right, d phi by dt, which is equal to now d by dt of flux is b into a. So magnetic field is constant field, so b outside into d by dt of area is length into breadth, right? So breadth is here constant everywhere, length is varying out of the magnetic field. So you can say this is b into what you can write dl by dt. The rate at which length is changing is velocity, so you can say write b into v. This is the induced EMF across the cut wherever the small cut is there. If it is closed, induced current will flow. Now simplify the expression. So b, how much value of b is given? B value is 0.3 Tesla. So 0.3 Tesla. So 0.3 Tesla into breadth. Breadth is 3 centimeters. So 10 power minus 2 into v. V value how much given? Just check it. V value is 2 centimeter per second. Convert in meter per second, that one. So 2 centimeter means 10 power minus 2 per second means meter per second. This SI unit will come. Okay, volts. If you simplify, 0.9 into 2 into 10 power minus 4 volts. This is 1.8 into 10 power minus 4 volts or 0.18 millivolts, you can say. So once cross check the options what he has given, 0.1 or 1.8 in 10 power minus 4. Yeah, that is which option is correct? That will be first option will be correct. Fine, students. Yeah. So this is EMI, electromagnetic induction, motional EMF concept. Okay, right, students. And next we can talk about galvanometer of resistance 100 ohm gives a full scale deflection. Yeah, conversion of galvanometer into ammeter. So we connect a small resistance in parallel, we call shunt resistance, isn't it? So galvanometer resistance 100 ohm gives a full scale deflection for a current of 1 milliampere. It is converted into ammeter of range 0 to 10 amperes. It has to, okay, 0 to 10. So maximum current is I 10 ampere. The shunt required is, okay, let's just solve this question here. Now 12th question. So we are having a galvanometer of 100 ohm resistance. Okay, so galvanometer of 100 ohm resistance we are having, and we are connecting a small resistance shunt in parallel here, and this is carrying a maximum current of how much here, 10 ampere. Out of this, for full scale deflection, galvanometer is carrying how much current? Galvanometer deflection for a current of 1 milliampere. So maximum current through galvanometer is 1 milliampere. When you connect how much shunt resistance, so then this will behave like a ammeter which measures current of 10 ampere. So you can see a simple principle here, students. When you connect here a galvanometer and shunt resistance are in parallel, potential difference is same. That principle we use here, isn't it? Now if you see a potential difference across the galvanometer is equal potential difference, okay, potential difference galvanometer is equal potential difference across what? Shunt resistance. Potential difference formula is what? I into R. Yes or no? So current through galvanometer into its resistance is equal to remaining current out of this 10. Remaining current is I minus Ig here. So I minus Ig into what? Shunt resistance. Okay. Potential formula is what? V is equal to I into R. Do you agree or not? Yes. So this form sent value you have to find out, which is equal to Ig into G by I minus Ig. If you remember this formula also, okay, your time will be saved in competitive. So shunt will be Ig, current is 1 milliampere, 10 power minus 3, and galvanometer resistance is 100 ohms, so 10 power 2. Total current is 10 minus current through this one is 1 milliampere gone means 10 minus 0.001 milliampere, no? So this will be how much? 9.9, how much? You can do 0.0019, no? So 10 minus 9, so 9.999, okay, 9.999. So if you see this approximately 0.1, okay, this will be 10 power minus 1 by approximately 0.1 means how much will have? 10 minus 9.9, 1.1 you can say, right? 10 9.9, so you can say 0.1 means 10 power minus 1 you can take. If you go up, approximately 1 ohm. Let us see options. Yeah, approximately 1 ohm is over there. Okay. Yeah, calculation should be careful. Okay. So this is question based on what? Galvanometer converted into ammeter. Similarly, you can expect how galvanometer converted into voltmeter. So if you have to connect what? A large resistance in series. Okay. Right. Now coming for Young's double slit experiment using monochromatic light of wavelength lambda. 13th question, right? Intensity of light at a point on the screen where the path difference is lambda is k units. The intensity of light at a point where the path difference lambda by 3. If you see this question as it is NCERT question, NCERT problem, okay, which is given at the end of the chapter, as it is question it is, okay. I remember the answer, k by 4 I think. Let us solve it, no issue. So in Young's double slit experiment, okay, where path difference lambda, intensity I, when path difference is lambda, intensity is k. The intensity lambda path difference lambda by 3. Okay, let us solve it. Now you see, just will include a paper here. Yeah, you can see here in inter YDS, right? So what is the formula for intensity, students? So intensity I is I maximum, that is 4 I naught, okay, into cos square 5 by 2 formula we know, where maximum intensity is 4 I naught provided amplitudes are equal, right? Or else A1 plus A2 whole square. So in this one, phase difference, the first of all phase difference, path difference, what the formula we know, 2 pi by lambda into path difference, right? So when path difference is lambda, intensity is I, he is saying. So when path difference is lambda, 2 pi by lambda into lambda. So phase difference will be how much, students? 2 pi radius. When phase difference 2 pi, substitute here, that intensity I is equal to k, he is saying. So which is I maximum, okay, I maximum into, so you can write cos square 5 by 2. This is 2 pi by 2. How much will get, right? Which is equal to maximum intensity at the point is equal to, or k is equal to I max into cos 180 is minus 1 whole square plus 1. So this is equation number 1, that is k. Now when path difference is lambda by 3, when path difference is lambda, when new phase difference how much? 2 pi by lambda into lambda by 3 you can do. which is equal to 2 pi by 3 radians. Okay, substitute over the intensity now. That intensity is here I max into cos square 5 by 2 means 2 pi by 3 by 2 students. So this will be cos 60, cos pi by 3 is 60 degrees, right? Pi by 3 is 60 degrees. So cos 60 1 by 2 whole square, that is I maximum by 4. But in the first case, I maximum value how much came equal to k? So this will be now k by 4. Okay, as the NCERT question, focus on that question. Okay, so which option is correct now? That comes out to be, yeah, k by 4, A option. Next you see here, magnitude and direction of the acceleration produced in a body of mass 5 kg when two mutually perpendicular forces 8 and 6 act on a are respectively. Direction and magnitude is asking. Okay, so how much magnitude of forces? 6 and 8 and 6 Newton. Okay, magnitude of force in the body of mass when two mutually perpendicular forces 8 and 6. Okay, let us draw the diagram now. So if you see this question, one is 8 Newton and there is how much? 6 Newton. These two are perpendicular. You know parallelogram law of resultant will what? Diagonal passing through common vertex. This value will be how much? These two are perpendicular, right? Resultant will be 6 square plus 8 square. Root 100 how much, right? That is how much? 10. So I can say this is equal to 10 Newton. So this is 10 Newton. So if I take with theta with 8 Newton is theta if you consider. So tan theta will be opposite by adjacent. Opposite how much beta? 6 Newton. Adjacent how much, right? 8 Newton. So this will be 3 by 4. Okay, like tan theta of 3 by 4 for what value? 37 degrees, isn't it? Sin 37 by cos 37. So theta will be 37 degrees with 8 Newton and 53 with 6 Newton. So just see the option and mark it. That is question number, which one it is? Yeah, this is question number 14. 2 meters high. Acceleration how much now? Acceleration is force by mass. So force how much given? 10 Newton and mass how much? 5 kg. So mass value is given, 5 kg. So force is 10, mass is 5. So will be how? 2 meter per second square acceleration, and direction is what? Direction of acceleration, direction of net force. So net force direction is 37 degree with 8 Newton. So correspondingly you can mark the option. Which option there? So tan inverse of 3 by 4, 3 by 4 with 8 Newton. Okay, 2 meter per second square. 3 by 4 with 8 Newton. So option 3. Okay, sometimes they may change options also, order also, should be careful. Okay, yeah. So here capacitors given question. All are equal 10 microfarad and C5 is 2.5 along with a battery of 50 volts. Okay, same this question also in NCERT. Okay, you can see example questions it is given. Example I mean exercise backside question it is. Okay, so right, so capacitor, electrostatics it is. Okay, equivalent capacitors and a charge on the each capacitor. Yeah, if you see this, these all are how they are beta? They are in series. In series all are identical, right? So when identical capacitance formula is what? 1 by C in series, 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4. So 1 by C equivalent is 4 by C. Do you agree? So you can solve it here. I will include paper. Yeah. So R1 by C is equal to 1 by C 4 times repeating, right? So which is equal, this is C equivalent. So C equivalent will be C by 4. Each value how much beta? Each value is 10 microfarad. So this is 10 microfarad by 4. 5 by 2 means 2.5 microfarad is capacitance of each capacitor. Okay, 4. And then this is in parallel with C5, right? So this equivalent capacitor of 4 is this one. Okay, so and then this is in parallel with 2.5 microfarad and one more battery is here. Correct, I'm drawing once cross check. Yeah, these are 4 in series. They will come in parallel with C5 and C5 value how much? 2.5 microfarad. So you can connect here 2.5 and this is also 2.5 and they are in parallel. In parallel we add. So C value will be C1 plus C2, that is equal to 5 microfarad C value. And battery value how much given? That is 50 volts battery connected. So what is asking? So same potential will be here also, isn't it? And moreover they are in parallel, right? C5 and resultant value. So across this across this also for 50 volts, across this combination also 50 volts. Okay, what is the charge will be? Potential is same, no? C is equal Q by V. C is equal to how much? Q by V. and Q is equal to C into V. So C into V. So you can say this also for 2.5. So across just I am just finding the combination. Potential is same, no? So charge I am finding. Charge will be how much? C into V. So C will be is 2.5 and this is 50. So you can calculate, this becomes 125 microfarad, no? So micro coulombs you will get. So 125 micro coulomb on each, on this one as well as this one. But this is resultant of how many? 4. So how many resultant is 4. So each will have same charge. Why? In series combination each capacitor will have same charge. So on each will be, on this one 125 and remaining also 125. So and this 125 remains same on each. Why? They are in series. So resultant capacitance is how much we got? 5 microfarad, and charge on each capacitor is, charge on the each capacitor respectively, so charge on the each capacitor will be 125 microcoulomb. Okay. So let's see, Q is equal C into V. So on this one also same, no? As they are in parallel, 2.5 microfarad into 50. So 125. 125 microcoulomb, and same also we got, no? So all of them will have 125 microcoulomb. Okay, so you can mark 5 microfarad is net equivalent capacitance. Okay, and charge on each one will be is equal 125 microcoulomb. Okay, right. So next, if you go here, this question is based on what you can call meter bridge, right? In a meter bridge experiment, the position of the cell and galvanometer G are interchanged. So we should observe in the galvanometer. If you change, already in the class also we generally discuss this one. So when your battery and galvanometer interchanged, so the length of the balance length will not change. R1 by R2 is equal to L1 by L2. Okay, so only thing, deflections if you see, no? So positive based on this length. Okay, so the positive and negative deflections will happen. So there are no deflection in respect of the position of the jockey. That is true. By both right hand side, left hand deflections, and a bed balance point, no deflection. Deflection means both right and left sided deflection, and at a balance point no deflection. At a balance point no deflection, and both right and left deflections you can find out. So you can mark as 4 here. Now next question based on work energy power, students. Okay, power of a crane which lifts a mass of 1000 kg to a height of 20 meter in 10 seconds. So power formula is what? Rate of doing work, or work done by 10 average power. So we are lifting it against gravity. So work done will be change in potential energy. So mgh I will say, and reference I will take 0. Change in potential energy mgh minus 0 mgh by time taken. Can you simplify this? How much you can now? So mass will be 1000, 10 power 3, and g value you can take 9.8 into height value. How much? Height is 20 meter by time is 10 second. 10 to 0. So 19.6 kilowatts. So that is kilowatt. Keep in mind. Oh, you should be careful here. This is watt, this is kilowatt. So answer is 4. Okay, in a hurry. So answer is 4. Next you can see, students, match the column 1 with column 2. Young's modulus. Direct formula, Young's stress by strain. Young's formula is what? Y is equal stress by strain delta L by L. So FL by delta L. So this option 2. Compressibility, reciprocal of bulk modulus. What is bulk modulus? Compressibility, how we define? Compressibility we have defined as reciprocal of bulk modulus. Okay, so 1 by B is equal to K, you can say, or K is equal to 1 by B. So 1 by B means delta P, of course, minus it is on increasing pressure volume decreases, delta V by will go up. So delta V by delta P. So this option C, therefore 3. And bulk modulus, that formula, P by delta V by V, that is 4. Solid, this is elasticity. Okay, Poisson's ratio, lateral strain to longitudinal strain, right? Lateral strain to longitudinal strain. Delta D by delta L by L. So this option here 1. So this one. So 2, 3, 4, 1. 2, 3, 4, 1. This boy correctly did. This is 4th option. Okay, right. So this is based on elasticity question, basic definitions. Okay. Now next we will go for what, students? In a concave lens, a ray of light emerging from the object parallel to principal axis of the lens after diffraction. In a concave lens, a ray of light emanating from the object. Okay, in a convex lens, concave lens, a ray of light emanating from the object parallel to principal axis of the lens after refraction appears to diverge from the first focus, isn't it? In parallel ray, if you have seen, in a parallel race are coming from long distance object, they get diverged. If you produce a light rays backward, no, so what happens? So they appears to come from first focus. Okay, that is the answer. Next, coming for a thin wire of length L and linear mass density is bent into a circular ring. Okay, the moment of inertia of the ring about an axis y dash. Okay, yeah, thin wire of length L and linear mass density m, mass per unit length. Okay, so m, so mass per unit length, so mass per unit length is linear mass density, so mass will be m into L. Okay, now a tangential axis, no, if you consider about this axis, what, mr square, and about diametrical axis will be mr square by 2. Yes or no? Do you remember the formula is? So in a circular ring passing through center of mass perpendicular to plane is mr square. Diametrical axis will be x axis plus y axis is equal to z axis. Now z axis is mr square. So x and y will be mr square by 2. Now about y dash will be, again apply parallel axis theorem. So we will have, listen carefully. So about this axis, right? So about this axis, this is AB. So moment of inertia about y dash is equal moment of inertia about AB plus mass of the object times square of the distance between them, and radius how much here, wire of length L it is, no? Yeah, radius some r you can take, that is mr square, and here you can write, keep in mind, so 2 pi r is equal to L, length is L, no? So r will be L by 2 pi. Okay, let us simplify here down, right? Now mass per unit length is m by EL, so mass will be m into L. Okay, and as he's saying, moment of inertia about this axis is asking. Okay, tangential axis. Moment of inertia about this axis will be how much? Mass of the object times r square by 4. R square by 2 here, right? About perpendicular axis mr square. Parallel axis passing through center will be mr square by 2. Now moment of inertia about this y dash will be moment of inertia about this passing through center in the plane of the circular frame is mr square by 2. Okay, plus this radius is r, if you see, this is entire mass times r square. Okay, so this will be how much beta? 3 by 2, this is capital R, 3 by 2 mr square. So moment of inertia 3 by 2 m. M will be how much? M into L, small m into L, and r value will be, length will be 2 pi r, so r will be L by 2 pi. Just substitute here, this becomes L square by 4 pi r square, so this becomes 3 by 8 m L cube by pi r square. Okay, so you can simplify the marks, and 3 by 8 is 3 by 8, all options are 3 by 8. Next ml cube by pi r square, ml cube by pi r square, sorry, pi square, ml cube by pi square. Mark carefully, because don't be in hurry. So option A will, this boy has marked right, so 3 ml cube by 8 pi square. Yeah, density of the metal of the can be best represented. Yeah, each side of metallic cube of mass this much is measured to be 9 centimeter. Keep the significant figures in mind. You have to answer its density. Density formula is what beta? Density is mass by volume. So mass will be 5.580 by volume is 9 centimeter cube, 9.0. Okay, 9 means 20. Yeah, 9 into 9 you have to write cube. Go. So this is 81 centimeter cube. Okay, but answer is kilogram per meter cube is asking. So this is kg numerator. So you can convert this one in 5.580 by 9 into 81. Okay, so this is centimeter, no? So powers of 10 you can't take. So 8 ones are 8, 9 ones are 9, 9 ones are 9, 9 8s are 72. So 729 into this value in meters. If you take 10 power minus 6 meter cube, so this becomes kilogram per meter cube. But see, in multiplication division we consider significant figures, in multiplicants least number of significant figures. So here 9.0 has 2 significant figures, trailing 0 with decimal is counted. Okay, 2. So you should significant, you should round it off to 2 significant figures. That means you can take this one as 5.580 divided by 2 significant means decimals తీసుకోండి ఇక్కడ. Then multipliers 2, no? So you can write as, anyhow this is coming to be 7.29 into 10 power minus 4 రాసుకున్నా కూడా ఇంకో విషయం, 2 decimals, right? These are anyhow 723 significant figures are there, and here if you consider 1 2 3 4, okay, 4 significant figures are there. So, and in division or multiplication you have to express the answer in terms of least number of multiplicand figures. So multiplicants x into y into z are multiplying, among that which has least number, that you have to round it off. And division also, out of 2, numerator and denominator, which one has least number of significant figures, that you have to. So numerator has 4 significant figures, denominator has 3 significant figures. So you have to express the answer finally in terms of 3 significant figures. So out of the given, so this will be 3 significant figures. Okay, yeah. Next you see, traveling wave equation is given, right? A sin some a cos omega t minus kx form plus 5. Okay, the phase difference between the oscillatory motion of 2 points separated by a distance of 0.5 meter. Yeah, so path difference and phase difference you know very well. Delta phi is equal to 2 pi by lambda into path difference. So you can use this formula into path difference, and here 2 pi by lambda means this is k is to be like k into delta x. So k value how much from this one? Compare this equation with y is equal to a cos some omega t minus kx plus some phi form. Okay, so omega t value how much? 2 pi into 10, and kx value, how much right here? Phase difference you have to find out, right? K value how much? 2 pi into this 2 pi multiplied, no, 8 into 10 power minus 3, 8 into 10 power minus 3 into delta x is 0.5 meter you have to consider, that is 0.5 meters. So simplify this one, and that comes out to be how much? 0.5 into 2 is 1, 8 pi into 10 power minus 3 nana, that will be 0.008 pi. Okay, 0.0, yeah, this is right answer. So wave equation comparison, finding value of k, delta phi is 2 pi by lambda into path difference. Okay, yeah, like this. So you have to fast you have to solve, right? Now 22nd third question, a ray of monochromatic light is passing through a equilateral prism. Okay, the reflected ray is parallel to its base, means prism is in minimum deviation condition. In that case, angle of incidence is equal to angle of emergence, delta is equal to I1 plus this is emergence I2 minus a. So incidence value how much given? 50. So emergence also 50. Equilators was 60. So 50 plus 50 how much better? 100. 100 minus 60 is how much, right? That is 40 degrees is angle of deviation. Direct formula based question is, that is option A, students. Okay, now this question is looking like half wave rectifier. In the circuit shown below, voltage appearing across the diode D will be in the form, of the form. Okay, you are giving sinusoidal signal, plus minus you are giving during positive cycle. Okay, if you consider here plus and minus, positive cycle it won't conduct, negative cycle it conducts. So and next negative positive will conduct, will not conduct, so alternatively. So first it conducts, half cycle only comes, no. So if you take this positive, this negative, this will be positive, means it conducts, so output will be there. And next when negative cycle it won't conduct. Next again when good positive it's conduct. So only half wave rectifier రావాలి కాబట్టి మీకు ఆన్సర్ ఏం రావాలి? పల్సైడ్, ప్రతి దాంట్లో రాదు, సో హాఫ్లో రావాలి మీకు. సో లైక్ ఫస్ట్ హాఫ్లో వస్తుంది అనుకుందాం, నెక్స్ట్ హాఫ్లో రాదు, మళ్ళీ నెక్స్ట్ హాఫ్లో వస్తుంది, అట్లా రావాలి, అవునా? సో ఐ థింక్ this part you can mark as second one. Okay, full wave rectifier, what happens? Both cycles will get output like this format. Okay, right, Nana. And next we can see here, next question, yeah, over, no? So next here, for a simple pendulum having time period t, the variation of kinetic energy with time t is represented. Okay, this question same way in JE also, this question repeated, frequency is asked. Okay, so if you consider simple pendulum, so yeah, time period of oscillation, so time taken for one complete oscillation we call as time period, isn't it? So displacement versus time graph, if you draw here like this. Okay, and moreover in case of simple pendulum, if you observe, when you pull the bob aside and leave it, it starts performing oscillations. Now from mean to extreme position t by 4, again here t by 4, again t by 4, again t by 4. Okay, total time is t. But in one time period, how many times kinetic energy becoming maximum ray? So mean position start here maximum, 0 at extreme, again maximum, goes this side 0, again try to become maximum. So before complete in one oscillation, 2 times potential energy and kinetic energy becoming maximum. So time period of pendulum, if it is t, time period of oscillation of the energy will be t by 2. Okay, and frequency will be double. So in that sense, if you answer this question, okay, so you can see here, yeah, time kinetic energy is t by 2, fine. And moreover, kinetic energy cannot be negative, always it is positive. Okay, this is positive cycle shown, this positive negative, no, it cannot be, it cannot be constant. Okay, variable. Why? If you see, the instantaneous position of a particle performing SHM is equal x is equal a sin omega t. Yes or no? Its velocity will be how much? A omega cos omega to just differentiate it. And when you find kinetic energy formula, this will be half m v square. V square means a square omega square cos square omega t. Here sometimes if you average, if you ask, no, cos square omega t average 1 by 2, it become 1 by 4 and all. Okay, so now here we have to find kinetic energy profile graph, cos square graph. Normal cos graph, how it is? Like this. Cos square means it is also periodically varying, but all positive values. So all positive values, periodically but varying here. So you can say the graph value will be, okay, so it cannot be constant. So similar, I mean sin తీసుకుంటే cos వస్తుంది, cos తీసుకుంటే sin వస్తుంది కాబట్టి periodic all values are positive కాబట్టి the graph will be like this. If I take sin, cos వస్తుంది, and cos తీసుకుంటే మీకు sin వస్తుంది, displacement equation. So ఇలా వేరీ అవుతుంది. సో కాబట్టి మీ గ్రాఫ్ ఇది మార్క్ చేయాలి. Okay, understanding? Yeah, cannot be constant. Yeah, resistor is connected to a battery of 12 volts internal resistance. The current in the circuit is 0.3 terminal voltage. Yeah, for a discharging battery, terminal voltage we have seen. So for example, a battery or EMF here like this, current battery of an internal resistance is 2 ohm. 2 ohm. Current in the circuit is some load resistance capital R. So when it is discharging battery, terminal voltage will be how much? Formula Vt is equal to EMF minus I into R. So you can find out current also he only gave, we did not calculate. So terminal potential E value, EMF is 12 volts minus current is 0.6, resistance value, okay, load resistance not there, only internal resistance. So whatever the entire EMF minus potential drop across this 2 ohm, that is the remaining potential across this capital R, isn't it? So capital R, potential drop across R, our terminal potential will be total EMF minus drop across internal resistance E minus I into R. So this is 2, which is equal to 12 minus 1.2, that is 10.8. Okay, so this is the answer. Okay, all of you. So terminal potential, characteristic question. Now here amount of work done to raise a mass m from the surface of the earth to height equal to radius of the earth, is saying. So change in potential energy, you know, students, all of you. By conversion you can do, a direct formula also remember. So change in potential energy formula is what? mgh by 1 plus h by r. Okay, r you can simply take like this, students. Resistance radius is r. On the surface potential energy how much? Minus g capital M small m by r. Small m, this is capital M. If you rise to a height, h is equal to r. At this time potential energy will be minus g capital M small m by r plus h, means r plus r, which becomes how much? It becomes how much? Minus g capital M small m by 2r. So we are lifting the object against what? Gravity. So work done will be change in potential energy. So final minus initial. So final is minus g capital M small m by 2r. So minus of minus will be plus, and initial value will be g mm by r. So you will have g capital M small m by r. If you take common, 1 minus 1 by 2 is 1 by 2. So we will be having g capital M small m by 2r. Yes or no? And g formula is gm by r square. So in that sense, m into gr square by 2r, students. So this becomes how much better? mgr divided by 2. mgr divided by what? 2. So in terms of g is asking, no? So this will be answer for this question. Okay, now coming for Next question, electric heater supplies heat to a system, okay, at the rate of, how much at the rate of, so 100 watt. If the system performs work at the rate of 75 joule, then the rate at which inter energy, right, formula it is dq is equal to, you can write du plus dw, okay, input and output, no, how much consume you can see. Electric heater supplies a heater to a system of rate at the rate of 100 watt power, okay. System performs work rate of 75 joule per second, so work done is 75 watt, inter energy is 25, output is 75, input is 100, difference how much, 25 joule per second, so you can mark directly as what, 25 watt. Now coming for a room heater is heated to 400 watt to 20 volts, the supply voltage 200 volts, what will be the power consumed, that v square by r, okay. See, from rated we calculate resistance beta, rated values we calculate resistance is v square by p, v given, p given, and if the supply voltage drops to 200 volts, okay, so rated resistance is same, okay, so power is equal to I square r, okay. From this resistance you can calculate, resistance depends on the rated voltage, so room heater is rated at 400 watt to 20 volts, resistance is constant, okay. So power you can use the formula v square by r, so here r is what, constant, so power depends on supplied voltage here now. So supplied voltage drops to half, means power drops to 1/4. 1/4 means 1/4 of 400, it comes out to be 1 minute, 29 question, no? 29. So this is bulbar heater rated at 220 volts and 400 watt. It is rated, room heater is rated 400 watt to 20 volts, so 400 watt. So from this resistance is equal to v square by power rated, so resistance is 220 into 220 by power is 400, so 484 by 4, that is 121 ohms, okay. Next, what is saying, now when this heater coil operated at potential of some v volts, okay, then the question, what is asking question, the system perform work, not sorry, the supply voltage drops to 200 volts, what will be the power consumed approximately, okay. Now you see, rated from resistance we got, resistance is 121 ohms, okay. So if rated voltage, power supplied is dropped, no, so I is equal to v by r, resistance is constant, when v drops I also drops, resistance is same, resistance not going to change, so when v is drops to v by 2, current also drops to what, I by 2, when current drops to I by 2, what is asking, power, power consumed is I square r, okay. I square r means this is equal to v square by r square into r, this becomes v square by r, okay. V value how much now, depending direct fluid formula, voltage only, so p dash by p is equal to, you can use formula v dash by v whole square, r is constant, so p dash is equal p into v dash is v by 2 by v whole power 2, so p dash is equal to p by 4, you can substitute the values, okay. Yeah, so next you can say here what is giving, approximately 1/4 and 121 తీసుకోవచ్చు మీరు, ఓకేనా. Yeah, so next you can see, when a ruler falls vertically, ruler falls scale kind of thing, 5 different persons catch with different reaction times, okay. So suddenly when they are catching, so if reaction time more means what, travels more distance, so when a ruler falls vertically, 5 different persons catch with different reaction times, okay. So in falling, no, so when they catching different reaction time means when suddenly when sees, immediately he may catch, okay. After some time he's holding means it falls larger distance, so if you're taking more time means it falls through larger distance, in that sense you can answer this question, okay. Then tarvata, consider uncharged capacitor of equal capacitance 200 picofarad, one of them is charged by 100 volts and disconnected. Now this capacitor is, every time this model is getting repeated, Now this capacitor is connected to the uncharged capacitor, amount of electrostatic energy lost in the process. Okay, you can find initial potential energy. Okay, then energy stored in the capacitor, calculate after connection for the final potential energy. Difference in energy is what? Energy lost. Okay, now capacitor how much here? We'll do the question here. So ఒక నిమిషం. Uncharged capacitor, equal capacitance of 200 picofarad. Okay, so equal capacitance of 200 picofarad. Okay, question number 31. Now you see, when you connect it better, so I have a capacitor of capacitance C. Okay, and what is the energy stored in the capacitor formula is half C V square. So half C is 200, pico means 10 power minus 12, and initial voltage how much? We'll check it. So initial voltage 100 volts. So 100 volt whole square is 10 power 4. This one. So what the initial energy will be? 6. So 10 power minus 6 joules. Now when it is connected to another uncharged capacitor. Okay. So this will be charged to what potential? 100 volts. Okay. So C is equal to Q by V. So Q will be is equal to C into V. Okay. Initial charge. Now common potential will be how much here you can calculate. So common potential. Finally see, when this is charged to 100 volts, you are storing charge up to how much volts? C into V. So Q is 200 into 10 power minus 2 into 12. Voltage is 100. So this becomes 2 into 10 power minus 8. That means this will be 0.02 microcoulombs. Okay, we're following. So Q is equal to C into V. 200 picofarad, voltage is 100 volts. So 2 into 10 power 4, 2 into 10 power minus 8, 0. microcoulomb. This is the initial charge. Okay, charge remains the same as you are disconnecting the battery. Now this charge will be saved by these two till both of them acquire the same charge, the same potential. So what is common potential? C1 V1 plus C2 V2 by C1 plus C2. Like this you can do. Or potential is 200 volts, identical capacitor. So potential becomes what? Equal. Okay. So initial C, potential is V. This is initial uncharged capacitor. So 0 by 2C. So you can say potential becomes half. So 100 means this will be 50 volts. This will also be 50 volts. Okay. Now, so how much final energy in the capacitor? Final energy is half into its C into V square. So both are there parallel and each will be equal to V by 2. So kabatti V square. So V square kabatti ento vastundana half C V square means V square by 4. Okay, half C V square by 4. So this is already we found, right? So initial ఎంత వస్తుంది మనకు 10 power minus 6 by 4 ఇప్పుడు అంటే 10 power minus 6 by 4 is final energy. Energy last will be how much? So difference in energy is equal to final energy minus negative వస్తుంది, negative indicates loss. So 1 by 4 minus 1 into 10 power minus 6 nana. This is minus 3 by 4 into 10 power minus 6 joules. Okay, you can mark by simplifying you can mark the answer. Okay, 0.5 into half of the energy will last. Initial half C V square, finally is half C V square by V is V by 2, no? And capacitance will be system this call kada parallel 2C. So this is 2 into C. So this will be 2. So half C V square by 2 means half is last. So before was 1 by 2. Okay, means then the 0.5 into 10 power minus 6. Yeah, this will be the answer. Okay, initial 10 power minus 6. So final capacitance is half into 2C into common potential V square by 4. 2 get cancelled. Calculation chudandi. So here 2C no. So 1 by 2 will come here. So this is 2 2s are no. So 1 by 2 means final energy is half only. So half of the energy is lost. So 0.5 in 10 power minus 6. half of the energy will be lost. Okay, right. And next we have about this one over, right? 31. So fast చేయాలి మనం డెఫినెట్గా కాంపిటేటివ్ ఎగ్జామ్స్లో. Savita, a 11th standard student, while conducting an experiment, determine the coefficient of length of a simple pendulum. Determine the effective length of a simple pendulum L. Note down a data of time taken to complete 30 oscillations in 60 seconds. So 30 oscillations, 60 seconds. One oscillation will be 60 by 30. That is 2 seconds. That means a pendulum is what pendulum? Seconds pendulum. So this is like a board question. So when pendulum having time period is 2 seconds. Length of time period formula is what? T is equal to 2 pi root of L by G. Right answer 1 meter, isn't it? Square it. So T square is 4 pi square into L by G. So here pi square is 9.8. So this 9.8, this can get cancelled. And this is 2 seconds. This is 4 into L. So L becomes how much? 1 meter. Okay. Peak value of an alternating current is 5 ampere and frequency is 60 hertz. How long will the current starting from 0 take to reach the peak value? So peak value will be how much, right? This is the 33rd question here. Alternating current, right? So total time of the pulse is, say, if we say t seconds. Okay, this is peak value, right? How much time? What is asking question? The peak value of an alternating current and frequency is 60 hertz. Time period will be 1 by 60. Okay, so how long will it take the current starting from 0 to reach the peak value? So peak value means 1/4 value. So here t by 2, here is t. So frequency is 60 hertz. You can calculate time period as 1 by frequency. So 1 by 60 seconds. 1 by 60 seconds time period will be. So from time taken to take from starting 0 to peak value. So this will be t by 4. So time taken to reach peak value is t by 4. This will be 1 by 4 of 1 by 60 seconds. How much, right? 1 by 240 seconds. Okay. So you can mark this question here, right? Now next you can see in interference diffraction the light energy is redistributed. That is what, right? True. If it is reduced in one region producing a dark fringe, it increases in another region. Conservation of energy, producing a bright fringe. Okay, there is no gain or loss of energy. These phenomena are consistent with the principle of conservation. It is true. Diffraction, interference are characterized only by light waves. Diffraction and interference are characteristics only by light waves. Sound waves also diffract, no? Why? We can observe practically when you're talking in one room, no? Side by other person can hear, no? Sound waves are bending and going. Bending property of light under the condition where size of the obstacle matches with the wavelength, right? So it can also observe in what? Sound waves also. Only light waves is wrong statement. So, and this is conservation of energy. Redistribution of energy in the region of superposition of waves, we call it as what? Interference. Okay. And diffraction also say maximas minima. We have seen in Huygens principle. Okay. So superposition of secondary wavelets result in the pattern of what? Diffraction pattern in single slit. So in that sense A is true and B is false. Okay. And a box of mass 15 kg kept on the floor of a stationary trolley. Okay. Block of mass how much? 15 kg on the floor of a stationary trolley. Coefficient of static friction between the box and the trolley is given, beta. That value mu is 0.12. Keeping the box in stationary state over the trolley. The maximum acceleration with which the trolley can be moved horizontally is, okay. See, when you are moving horizontally with this A, this box has a tendency of skidding in what direction? Backward direction. Then friction on it will be forward. So whatever the acceleration you are getting maximum, that is because of frictional force, isn't it? Divided by mass is the acceleration. Mu into n. So for this n value will be equal to its own weight, mg. So mu mg by mu. So what will you get, students? Maximum acceleration is mu into g. Just multiply. Mu value is 0.12, g is 10. So 0.1 into 10, that is equal to 1.2. Okay. So like this you can answer this question based on laws of motion and friction. Okay. Right. So you have to answer fast. So you have to do calculations also fast. Sum of kinetic energy and potential energy of a simple pendulum bob is 0.02 joules. The speed of the simple pendulum bob at equilibrium position is, yeah, equilibrium position. Okay, whenever force equation given, keep it x is equal F is equal to 0. Okay, restoring force, you will get there when you put F is equal to 0, any function if it gives, you will get mean position, right? If not given, you can take general position as mean position x is equal to 0 if you take. So when a simple pendulum or any particle SHM performing, no, x is equal to 0 plus a minus a. So here has maximum velocity, here velocity is 0, extreme position, here also 0. Now he's saying kinetic energy and potential energy of simple pendulum bob is 0.20. Okay, sum of total mechanical energy is given, right? So mechanical energy is given here. The speed of the simple pendulum bob at equilibrium, so maximum velocity will be, that is a omega. So energy is given, right? Of k a square. So speed of the simple pendulum bob at equilibrium position is, consider mass of the bob is, okay. So total energy is purely kinetic form at mean position. So I can simply say half mv square is total energy. How much? 0.02 beta. Mass is given how much? 20 grams. Okay. So this will be, can calculate down or else if you have space. Yeah, space is here. So kinetic energy is half mv square, and this value how much given? 0.02. So half into 2 grams, 2 into 10 power minus 3, this is v square, 2 into 10 power minus 2. So v square will be 2 into 10 power minus 2, this transfer right side, plus 1, 10. So v square will be, correct what you are doing? Yeah, v square will be 2 into 10. So v square is 20 means, 20, v will be 2 root 5. 4 5s, no? 2 into 2.2 something, so 4.4 something you should get. Velocity asking, right? 2 root 5. 2 root 5 half m, mass is 2 grams. 2 into 10 power minus, mass is 20 grams, sorry, 20 grams. So 20 and 10 10 వస్తుంది. About this becomes 10 power minus 2, this get cancelled. So v is equal root 2 వస్తుంది, right? When write v is equal root 2, 1.414. So this answer is right answer. See, calculation mistakes leads to wrong answer. Be careful, okay? Yeah. Statement A, for a mass number, I mean nuclear physics, I think. Volume of a nucleus is proportional to a power 1 by 3. R formula is R naught a power 1 by 3. Volume 4 by 3 pi r cube. If you do r cube proportional to a, so this answer is wrong. Volume of a nucleus proportional to a, this is right. Difference in mass of an atom and its nucleus is called mass defect. Difference in mass of an atom and its nucleus mass is called mass defect. Yeah. Difference in mass of the entire constituent of the atom minus mass of the nucleus is called what? Mass defect. Yeah. Difference in mass of a nucleus and its constituents is called the mass defect. Oh, if mass of an atom, no, we are talking the mass defect of a nucleus. No? Nuclear masses before they are forming a nucleus, nucleus mass, okay, when they are free, and when they form the nucleus, that mass, that difference is called mass defect, right? Difference in mass of a nucleus and its constituents is called mass defect. So here words B and D are true, but A and C are false. So option A is right. Okay. Yeah, getting late for me also. Fine. Now number of angular speed of a flywheel increased from 600 rpm to 1200 rpm in 10 seconds. Number of revolutions come to flywheel during this time. Okay, direct. So change in angular velocity, omega 1 is 600 rpm, omega 2 is 1200 rpm. Okay, you can convert in minutes rpm for rotation per minute to radian per second also you can do. Okay, change in angular velocity will get number of revolutions come to the flywheel during this time in 10 seconds. So change in angular velocity, how much is 600 rpms. So you can number of revolutions is total displacement by 2 pi. Okay, so you can take here average, you can take, so initial plus final by 2 is average angular velocity. So angular average displacement by total time, this will be how much, right? 600 plus 1200, increase to, no? How much will get? Let us solve it detail way. 38. Omega 1 is 600 rpm, rotations per minute. So rpm, which is equal to 600. One rotation means 2 pi radians per minute means 60 pi by 30. So 600 into pi by 30. So this will be 2 times, so that is 20 pi radian per second is initial angular. Double, no? This will be 40 pi. So what is average angular velocity? Will be angular displacement by time, which is equal to average value. Omega initial plus final by 2. 20 plus 40, how much raise? 60 pi by 2, which is equal to 30 pi. Okay. So now in 10 seconds, right? So total angular displacement will be 30 pi into 10. This will be 300 pi. So number of revolution is total angular displacement by 2 pi. So this is divided by 2 pi. That will be some nearly 150. Okay. So yeah, nearly 150 angular displacement. Yeah. Next we have submarine is designed to withstand an absolute pressure of 100 atmosphere. How deep it can go? Direct question you can write. So pressure because of fluid is H rho z. Okay, you can calculate from that one. Absolute pressure means net pressure, means only because of liquid. Total pressure is atmospheric pressure plus pressure because of the liquid. So submarine designed to withstand an absolute pressure of 100 atmosphere. How deep can it go? Okay, consider density of water 1 atmosphere. So P is equal to H rho z. Okay, a gauge pressure means only because of liquid. Absolute means total pressure. So atmospheric pressure plus H rho z. Okay, so from there atmospheric pressure plus H rho z calculate equal to, okay, total pressure, and from there you find the value of H. So hope you will do this question, right? Formula based only. Now next again electromagnetic radiations, microwaves and visible light, vibrations of atoms and air molecules, gamma rays, infrared rays. Electrons in atoms emit light when they move from a higher energy level to a lower energy level. That is true. Next visible region, vibration of atoms and molecules, gamma rays, radioactive decay of nucleus, gamma rays. So C will be 2. Where matching? C will be 2. So in all it's matching. Next, microwaves, klystron wall or magnetron wall. You have to read electromagnetic properties of electromagnetic radiation here. Okay, vibration of atoms and molecules. Radioactive decay is gamma, you can say. Gamma is radioactive decay. So C you can say 2. Infrared rays, electron in atom emit light when they move from a higher energy level to lower, emit in the form of photon. If you see Balmer series only visible region, right? So electron in atoms emit light. So you can say that visible rain, if you take visible light, if you take as 1, vibrations of atoms and molecule, infrared you can take. Okay, so B is 1 if you take, and C is 2 if you take these two, and infrared rays for infrared D3, vibration of atoms and molecules, infrared radiation you can take, right? Yeah. And microwaves will be klystron wall or magneton wall. Yes, A you can take 4. So like this you can match 4, 1, 2. So I can suggest option 4 here. Okay, and once carefully remember the frequency ranges, wavelength ranges, in which region they fall, and applications of electromagnetic radiation is important here. Okay, now which of the following statements are correct? Inside a conductor electric field is 0. Electric field is 0 under what conditions? Electrostatic conditions. Okay, so when you give any charge resides only on the outer surface, and E will be here 0 inside a conductor, excess charge outside. But general statement right? Inside a conductor electric field is 0. Not always true, because when you are conducting, by applying potential difference across the ends of a conductor, you made the current to flow. In that case, electric current is not 0. So that statement I will suggest as a wrong. Electric field surface of a charged conductor does not depend on surface charge density. See, electric field near the surface of any charged conductor is sigma by epsilon naught. It depends on charge density. So this statement is wrong. does not depend on it. It depends. Strong statement. Interior of a charged conductor can have no excess charge in the static situation. So when you are static situation, when you give charge, it always lies on the outer surface. So no excess charge inside. That it appears to be true. The surface of a charged conductor, electrostatic field must be normal to surface of every point. That is true. So electric field lines are always normal. Already we have seen in the classes also. If they have component along the surface, no, then that component of electric field along the surface will accelerate the charges. But condition is static condition, so surface charge should not accelerate. In that sense, definitely the field should have perpendicular to surface of the conductor. Okay, therefore this is right. And then in the the electrostatic potential is zero everywhere inside a charged conductor. Need not be, no, when a charged conductor surface of a conductor is equipotential, and if inside field is zero in static condition, so potential may be constant here. So electrostatic potential is zero everywhere inside a charged conductor. It may not be true. So what options are correct now? A, B, E are wrong, and C and D are correct. C and D. E only. E what is saying, right? Electrostatic potential is zero everywhere inside a charged conductor. Charged conductor. So conductor field is zero, no? So potential may be constant. Electrostatic potential is zero everywhere inside a charge. This statement seems to be wrong, man. Something differently has given. Are correct. Correct for my knowledge, C and D only. But something E is giving some doubt here. So most appropriate, you can mark 1, but that is also true kaadu. Electrostatic potential is zero everywhere inside a charged conductor. So electrostatic condition low, field zero, potential is constant. Electrostatic one dimension, no, potential zero, no, potential cannot be zero beta. Something obvious, ambiguous given it is. Okay. Yeah, let's see. Key also will be released, no? We'll see. Yeah, next. For a metal work function 6.6 electron volt, which of the following wavelength of incident radiation does not give rise to photoelectric effects? Okay. Work function again, wavelength you can calculate. So we have seen energy in electron volt is 12,400 by lambda in angstrom. So okay, nanometer Richard Gauti, you can take energy is 1240 nanometer by lambda in angstrom. Lambda you find out 1240 by 6.6. You will get some values to something. Okay, approximately if we take 200 nanometer. Okay, so maximum lambda is maximum wavelength below which, okay, photoelectric takes place, behind which no emission. So maximum wavelength itself is 200. Okay, so raised to photoelectric does not give. So this will coming out to be lambda must be lesser than lambda maximum. It should give, remaining will not give. So if approximately it is coming out to be some nearly 190 or 200, no, so this will give, but this won't give. Why? Because crossing the threshold wavelength. Okay, yeah. So the first excited state for hydrogen atom, the energy of its electron is this much. The radial distance of the electron from the hydrogen nucleus in this case is, yeah. So first excited state of hydrogen atom. Yeah, first excited state means what? N is equal to ground state 1, N is equal to first excited state. Okay. Yeah. The radial distance of the electron is a orbit, second orbit, N is equal to, what is the formula? 0.53 N square. Rn proportional to R naught into N square by Z, right? Hydrogen atom is asking. Hydrogen, so Z is equal to 1. So nth orbit radius. Here N is equal to 2 students. So you can write 0.53 into 4. So approximately 0.42, 2 point something into how much it is? R naught angstrom, right? Angstrom means 10 power minus 8 centimeter. 10 power minus 10 meter. So you can simplify this one. 2, 10 carry 1, 4 plus 4 is 12, carry 1, 4 for 20 plus 1 is 21, carry 2, 0 plus 2, so 2.12 angstroms. Okay, 2.12 angstroms, 10 power minus 10 meters, 1 angstrom 10 power minus 10 meters, so answer should be 4th. Okay, now you see Two statements are given below. When the forward bias voltage across the PN junction will increase above certain threshold value, the diode current increases significantly. That is true. This current is called reverse saturation current. No, and reverse bias because of what? Minority charge carriers. This is forward bias. No, the forward bias voltage. So the current is not reverse saturation current. So option A is true. Option B is false. My both statement A and B are true. Yeah, A and B are false. No. It meant A is true, B is false. So option 2 ray. Next, a flask contains argon and chlorine in the ratio of 2:1. The temperature of the mixture is this much. Ratio of root mean square speed. Okay. What formula for root mean square velocity beta? Vrms is under root of 3RT by molar mass. Yes or no? At a given temperature, right? So temperature constant. Just leave it. So V of which gas first? Argon. So V argon by V, which one given? Chlorine. Under root of inverse relation mass, no? So mass of chlorine by mass of argon, molar mass. So chlorine mass 70 molar mass, argon mass 40, yeah? 40. So you will have root 7 by 2. Every time mains and NEET question based on VRMS they are asking. Okay. So VRMS root 3 RT by M. So overall you can say paper is not that tough. Okay. Moderate or easy. But you have to calculate fast and you have to manage your time. So there your skill depends. So if you know standard value, if you have very good practice, no. If you have very good practice, you can do in a very easy way only questions. Okay. But as 45 questions compared to JE, no. Number of questions are more. So time taking will also be more definitely. So accordingly you have to solve. So okay, this is what your paper discussion for NEET. So hope you have done well. You can cross check your maximum solutions here, and you can please comment, post and share. Okay. Yeah, thank you all. So as we are doing already in my channel YouTube Physics Eknath Rao. I'm uploading all the corresponding videos. Second year modern physics over, and some part of kinematics, laws of motion, work energy power I have done. So listen those videos also. Please share among your friends. Okay. So thank you all. So hope you find this video useful for you. Yeah, thank you. Good day.